Yeah, so the title of the talk is Blockchain as Magic Internet Computer. But frankly, it covers like multiple topics. I must give this disclaimer that it's not like one cohesive train of thought. It covers multiple. But in preparation for this talk, because I presented this in the past a few times already, but in preparation for this instance of it, I tried to make it a little bit more suitable for new joiners, knowing that probably we have a lot of like people who joined Parity recently. And I hope it would be particularly useful for them. But as I was preparing to present it earlier today, I kind of realized I think it has something to offer, hopefully, for everyone, even if you have been around for a few years and you think you already know a lot of things. I hope there are like some corner cases or some thoughts that I can add to your understanding of blockchains. So yeah, what we'll cover today, we'll have a very brief introduction on what blockchains are. Then I will go into this like magic internet computer topic, and I would phrase it as a new perspective on what blockchains can be seen as, what blockchain systems can be seen as. Then really the most, for me, interesting part of this talk is then I will dissect for you what properties this computer has. And then we'll look at like how it has evolved over time. And then I would link these properties back to like how we can find a good use case for this technology, like topics like product market fit and why some narratives and ideas in blockchains like DeFi have been overwhelmingly successful and some others have gone nowhere. I have some guesses and some hypotheses on these topics that I would present to you throughout this talk. In some ways, I would, as a last point on my introduction, I must say this talk is the outcome of my personal exploration into like, what is this technology? Like, what is it useful for? What properties it has? What problems in the world we can solve with it, and so on. All right, so let's first get into our introduction. I want to start with this age-old example of owning digital money, Bitcoin, and how this whole industry started. So I would start with this very basic question. You own 100 euros worth of Bitcoin, and you own 100 euros in a bank of your choice. I use Revolut a lot, so I'm going to use them as an example here. Why is it that we think both of these monies are real? Like there's something valuable in it, and how they compare with one another. What is the differences between them? So first looking at like how the world used to work or still works, like the classic financial institutions work, namely Revolut in this example. So the first like reason we think this money is real is that, you know, this bank is registered in some country and these countries have central banks. Central banks are controlled by government. They put like balances and checks and balances into like what Revolut can do, and they bring some assurance into like your money not being lost. And again, remember, like most of our money these days is some number in a computer. That's all that it is. But central bank is not enough. Then it's usually backed by a judiciary system. So there's like courts and laws. If, for example, the bank of our choice and then the central bank violates some rule, this judiciary system kicks into place and gives us some assurance as users of these banks that, you know, if they misbehave, there is a police, there is someone to check them. There's someone to prevent them from doing that something wrong. And if they do, they will be punished for it. And finally, all of this is backed by some kind of law enforcement. Every country has like police, internal military, external military, so on. If there's no law enforcement, the judiciary system is kind of pointless. Like, okay, a judge says you have to go to prison. There's no one to enforce that. There's no point in that. So really the essence of it is law enforcement. And if you think about it, from my understanding, really like the trust we have in these institutions, it really like roots back down to law enforcement in every individual country. Now, in Bitcoin, there is no police in the world, as far as I know, who upholds the Bitcoin laws. So how is it that we think my 100 euros in Bitcoin is also, you know, something that I can trust in? Now, we use a set of technologies and branches of science to achieve the same outcome. So, for example, in Bitcoin, or all blockchains, let's say, we use extensively different branches of cryptography. Cryptography is a very interesting technology in that it's it's almost like military grade material. You know, like no matter who you are in the world or which country you belong to and what law enforcement exists in your country, you know, a public key signature behaves the same way. If a hash is irreversible, it's always irreversible. No police in the world can reverse it for you or vice versa. So this technology is kind of interesting in that regard. Something else that we extensively use is economic security or crypto economic security. And it really boils down to the fact that very often in blockchain-based systems, we incentivize good behavior by creating the likelihood of losing some value-bearing asset or money in this case. So for example, in proof-of-stake systems, some entities put some money on the table, and the system guarantees that if they misbehave, that money will be lost. And this creates an incentive for them to do the right thing or abide by the rules. It's almost the same in Bitcoin. You know, if you buy a miner rig in Bitcoin and run a malicious Bitcoin node, what you're doing in essence is losing money because you're wasting a ton of energy. And as long as the majority of the network is doing the right thing, you're just losing money. Something else that we often do is also re-execution. So these systems are filled with instances where, you know, one party does something, 5 other parties check it, or everyone else check it. There is a lot of instances of re-execution. And I would actually say these 3 are the main properties that, based on my understanding, yield that trust that we have in Bitcoin or any other blockchain. Actually, if you look at my list, the blockchain as a data structure is actually not part of that. And I'll get to this later in my talk. Yeah, I mean, for good or bad, we have come to a position where we have built systems that have, very interesting properties, and we call them blockchain systems. But this blockchain is just like one tiny part of it, and it's not even like the essence of it in many ways. But it's a good sort of disclaimer to give to all of you already that very often we use the term blockchain as an umbrella term for systems that are like loosely linked with blockchain or are using blockchain somewhere under the hood. But truthfully, there are more interesting technologies and properties used in these systems. But, you know, it is what it is. We cannot reverse history. Okay, so these elements of the Revolut system that I talked about, these usually yield a property that we call trust. We trust these institutions and so on. And when we combine this, like, you know, again, economic, probability, game theory, and some cryptography together, and we build something like Bitcoin, we tend to call that truth. In that, there is no single party, there's no human or institution in this combination of technologies that you're trusting to do the right thing. It does the right thing because, you know, these elements combined together happen to do the right thing, happen to be what we want. So this is where this like term, for example, less trust, more truth, very often used in Polkadot ecosystem comes from. I also like to call the truth part verifiable trust. I mean, you're still trusting in the same way that you trust like game theory to predict the world for you, or in the same way that you trust the hash function to not be reversed. You still have like this element of trust in it. It's just like a verifiable trust. It doesn't depend on, again, a human, an institution, or something doing the right thing. And what I want to get out of this introduction is that blockchains, by combining all these elements, yield something that I would like to model as a truthful computer, a computer that behaves in a very truthful way, like it does exactly what we ask it to do. Right. Let's now look at the properties of a blockchain if it's modeled as a computer. So let's begin. The first property that every computer has is that it has some code, it can execute it, and this code can, as the outcome of execution, modify some storage for us. So we have some code, we provide some input to this code. It could be like some instruction or some function call, the way you have it in programming languages. Because this computer is truthful, as I described it, we know that this code was then executed correctly. And then some storage, some piece of data was updated potentially by the code. And then we can look at this piece of data and also have very high guarantees that this data is now representing something true. So to summarize it, it gives us like truthful execution of code and storage of some data, whatever that data might be. Now, for example, if you look at Bitcoin and model it as like computer with these 3 elements I talked about, what is the code, the input, and the storage that the Bitcoin computer has? The code of the Bitcoin computer, excluding the sort of scripting language, is extremely simple. It's like a ledger of transactions that modify people's BTC balance. I mean, if we really want to simplify it, the code of it is just arithmetic that allows me to send Bitcoin to someone and receive some Bitcoin from somebody. The inputs to the Bitcoin computer are the transactions that we send. I want to send a transaction I want to send some Bitcoin to one of you guys. I go and open a wallet and send a transaction. That's like the input to the computer, the input that is then fed to the code. And the storage in the Bitcoin computer is just people's BTC balance. That's pretty much it. To look at it in a more visual way, we can frame it as such. So we have like the user sitting outside at the bottom, people who want to interact with this computer. They provide some input, be it in the form of transaction. This input is then given to the code of the computer, to the blockchain computer. And as the outcome of it, some storage is potentially updated. And then later on, we can look at that storage and, derive useful information. I can look at that storage and know how much Bitcoin I have, how much Bitcoin someone else has, and so on. All right, and then what is this pesky keyword blockchain all about? Frankly, the only reason we have blockchains as part of these systems is that, at some point, people realized, okay, if we have this like magic internet computer that lives on the internet, anyone can interact with it by sending some input and whatnot. For some use cases, that's actually not good because if I make a valid interaction with a computer and send some Bitcoin to someone, and then someone else makes another interaction with the computer, so also send some Bitcoin or something to someone, we need to know like in which order these two happened, because sometimes I might do this thing called double spend. I send something to you and in parallel I send it to someone else. I don't have enough money to cover both of them. So one of these two interactions are valid, the other one is not valid. And we need to figure out which sequence of events is the valid history of the computer up until this point. And this happens to be where we use this data structure called blockchain, where all of these inputs are bundled together as a block, and they're always linked to the previous one. There's plenty of resources on it online. Someone else can probably explain it better than me, so you can look it up later. But high level, I would say this blockchain data structure just adds another property to our computer, which is we have like auditable history. So someone can look back at the history and like check that everything, happened in this order. And it gives us a strict ordering. So, you don't have like some mess of events that happened and you don't really know if this happened first or that happened first. You know exactly, interactions with this computer happened in this particular order. Another very interesting property of this computer is that it's really, really public. Like it cannot avoid being public. So whatever is the code of that computer, so the logic of that computer, whatever inputs are given to them, and whatever storage is updated as a consequence of that input, in other words, transactions that we send to, for example, Bitcoin, are always public. And why is that? It's because of this re-execution. When we want to have re-execution by different parties, everything has to be public so that different parties can repeat the same process. I cannot do some private computation on my end and then expect the rest of the world to verify it if they cannot re-execute it. So publicity is a very important property of blockchain computers. Now, there's one branch of the technologies that actually, I would say in Polkadot, we haven't explored to the extent that maybe we should have. That actually changed this. It's usually called either zero knowledge proofs or snark proofs, or full FHE, fully homomorphic encryption. And both of these sort of sets of tools allow you to actually do computation on private data while allowing others to also repeat it. We don't particularly do these things, at least as of now, but they are the only sort of technology that allow us to sort of remove this publicity from the computer. One question here to ask is that when is public computation desirable? Very often when we want to have peer-to-peer interactions, I want to sell something to one of you guys, then it's actually good if some magic internet computer does something that I can verify it and this other person can also verify it. But if I'm building an application that is just me and my data, I'm storing my files somewhere, it's more tricky, or it's not as obvious why I want to do this on a public computer where the rest of the world can see I uploaded a terabyte of files now to some cloud. This is it's something to think about, I would say. Okay, another property of this computer, so far we covered that it's public and it has like code and storage, is that it's digital. So needless to say, this computer is, working on some bits in some computer. The authority that it has, like the enforcement that it has, is only in the realm of its own storage and the digital world. To make it an example, like when I have one Bitcoin, and for some reason now my Bitcoin balance is lowered to half a Bitcoin. Maybe I sent it, maybe I lost it, maybe I got slashed, whatever. This half a Bitcoin that I have right now, there doesn't need to be any like law enforcement for it. This half a Bitcoin is stored somewhere in the Bitcoin storage, and everyone can look at that and see that, okay, Kian has half a Bitcoin now, and it used to have one Bitcoin. Contrary, if I have this iPhone right now, and someone wants to dispute that, no, this is not Kian's iPhone, it's someone else's iPhone, there's no blockchain in the world that can, force this like real world interaction on me. So it's really important to keep in mind that this like authority or the law enforcement capabilities of blockchains is only limited to like the digital world and what they can like contain in their storage. Now, maybe a good and one thing that we hear a lot is that very often real world information and assets are brought to the blockchain systems. I don't want to say like all of those are a dead end and it's not going to go anywhere, but it's important to keep in mind that we are using blockchain systems with a different subset of their properties when we bridge real world assets to blockchains. Again, because there's no blockchain in the world that can enforce real world items to exist or belong to someone. We are using them mostly for the publicity aspect or the auditable history aspect, but not for that secure code execution and storage. And usually this problem that that I'm referring to here and talking about is called the Oracle problem. I think it's a good topic for new joiners to get into or do a bit of research on. Oracle problem is generally the fact that blockchains don't have a way to receive information from the real world. Even information like what is the price of gold today? How can a blockchain system know that without trusting some person to give it to it? It's a problem that is being solved in different aspects, but it's an important one and a difficult one. But reading is actually being solved. Sort of enforcing, I don't think it's actually even being solved, and it's much harder. And by enforcing, I mean, again, this bar of gold belongs to someone, and a blockchain system can enforce that. There's really no way to do that at the moment. Okay, and the other property that these systems have, and it's actually a keyword that we use a lot, but I kind of cover it last, is that they are decentralized. And decentralized systems are, by all means, or let's say by definition, more resilient. They are harder to stop. If you bring down a part of it, the rest of it probably can operate. So we use this keyword back in the days quite a lot in the Polkadot ecosystem, unstoppable. Maybe a funny story. At some point, I think the marketing and narrative changed to resilient, because unstoppable was a bit too harsh from a regulatory point of view, as far as I understood. So we changed the word to resilient in our material. But yeah, unstoppable still demonstrates it in a good way. To give an example, we don't know who or how many people have tried to bring down the Bitcoin network or Ethereum or other blockchains, but it's perceivable that bringing it down is, from some perspectives, harder than bringing a new bank down like Revolut, especially for nation states, for example, or for regulatory bodies. Like this FATF can probably mess with a lot of the banks that we use day to day, but they probably will have a harder time messing with Bitcoin. And decentralization is important to keep in mind that it's not like one keyboard with like a binary outcome. You are decentralized or not. It's completely a spectrum, and it's a spectrum among different axes. So one of them is like technologically decentralized, how actually, how much your technology is adhering to decentralization. Politically, like if a blockchain network is managed by people who live in one political jurisdiction or under the rule of one political party. And if that political party changes their mind about blockchains, what's going to happen to it? Or geographical, it's kind of interlinked with political because geography and politics usually go hand in hand. If you're in a different geography, you're usually subject to different political rules, or even things like ideologically decentralization. All right. And finally, all of this like nice properties, all of this dance to replace the trust with truth doesn't come for free. These systems, compared to like their counterpart in the real world, are similar to, I don't know, a 1980s CPU. You know, like we've created a CPU that is like 20 years behind in terms of performance, and you know, so it's so slow, but it has this additional properties, and it's important to not to forget about that. So they're usually slower to operate, and they're expensive to operate. But to recap, these are like some of the properties that so far I have identified for blockchains when we think about them as a computer. So they give you secure computation and storage. The history of all of this computation is ordered in a strict way, and it's auditable. And this is because we use the blockchain data structure. Everything they're doing is public, unless if they're using ZK technologies. They can enforce things on the digital world, but they cannot really enforce things in the real world. And they are decentralized, therefore they're kind of unstoppable. And the negative things that they have is that they are slow and expensive because they are decentralized. And something that I didn't mention in the previous slide, sometimes decentralization also comes with like, you know, the user is too much in control. There's no support hotline where you can call and say, hey, I lost my Bitcoin private key. Can you recover my account? That just simply doesn't exist. That being said, it doesn't always have to be that. Like we literally have like mechanisms in the Polkadot ecosystem. I think this thing is actually deployed on like Kusama network, for example. It's a system called social recovery. You can name like 5 friends, and if you lose your private key, those 5 friends can gather together and recover your account for you. Or another example, more recent, you know, sometimes it's said that Polkadot it's like a bit too decentralized to have like to meet business needs. You know, because there's no like one big enterprise that, you know, businesses can get an SLA from. But for example, we had recently a problem with someone buying all the core time on Polkadot, and one of the biggest customers, Mythical, was in problem. And Polkadot happens to have these decentralized kind of body of engineers that are meant to take care of the network, the fellowship, and they actually decided to take an action kind of outside of their normal routine and give some core time to Mythical, for example, so that they can continue to exist. So it doesn't have to be that if you're decentralized, you know, your support and business development has to be really bad, but it certainly becomes more difficult. All right. So next, let's look at how this like blockchain computer has evolved over time. Okay, I've already taken about like 20 minutes, so I'll speed it up a little bit. So first evolution, we usually call them dino coins, you know, like Bitcoin, Litecoin, maybe even Ripple, you know, like a lot of them are still around, but essentially all of these blockchains did one thing, like they had a fixed code and storage that you couldn't really like modify. Bitcoin happens to actually have like some scripting language, and a lot of people are trying to bring DeFi and so on to it. But if I exclude that for the sake of my talk, we can call them as like fixed code blockchains. They didn't really have a way to like evolve. You know, you code an application once, you deploy it, that's that. You hope this will be good for the rest of time. Then came Ethereum, and with it brought smart contracts, a smart way to make this like blockchain extensible. Though the blockchain still has like some fixed part that and does a number of things that are kind of like fixed, but it also accepts other people to like send some additional piece of code to it, and then it would run that for them. Actually, Ethereum is where this like world computer analogy is coming from, because it's very much like a serverless kind of cloud. You know, you write your code, you upload it to Ethereum, and then you can talk to that code. You can interact with that code. One shortcoming of smart contracts is that it's always like you're not renting a dedicated server to yourself. You're not even getting a VPS. Again, it's like a serverless computation. You are living on your code is being executed on some shared environment with a million other codes, and there are some limitations and drawbacks to it. But overall, it's a very good way to like, you know, allow for a lot of things to be experimented. And as all of you know, we are exactly bringing this natively to Polkadot as well. maybe a little bit of history of smart contracts of Polkadot is a little bit of history between like Polkadot and smart contracts as well, because I worry that, for someone who joined recently and knows that, in the year 2025, Polkadot is putting all of its efforts together to bring smart contracts to Polkadot. I wouldn't say it's because we didn't have the technology. Polkadot had like smart contract technologies from 2019, 2020, like Ink and like Pallet EVM, all the things that led to like Moonbeam, A-Star, Kala, all of these parachains launched with smart contracts. But the mindset was always that Polkadot natively shouldn't have smart contracts. It should be something that our users or parachains bring to the market. So, sometimes it seems a bit like late that only in 2025 we're bringing smart contracts to Polkadot, but it's for a deliberate reason. It's kind of intentional. And it's not only Ethereum in this realm. There's a lot of like blockchains that used to be called like ETH killers for meme-based reasons, like Solana, Near, and so on. They have like similar business models, or they have similar computation models. Okay, then we have this other approach, which is like instead of having one blockchain that can host like number of smart contracts, how about we kind of commoditized and give the whole blockchain package to someone? How about we build one blockchain that can host other blockchains on top of itself? And this gives the users who want to build things more freedom. You're not now limited to the small box of one smart contract. You can build your whole blockchain on top of some other platform. And this is where Polkadot and Cosmos were the first movers from like 2018, 2019, with a model that used to be called the multi-chain model, a thesis that said for every application, we need one specialized blockchain because its different applications require optimization on different angles. So you cannot have one blockchain that is optimized for all use cases. You better create like a platform where different people can launch different blockchain with different optimizations. And later on, actually, Ethereum also kind of adopted the same ideology with rollups, basically. So Ethereum rollups are very similar to what Polkadot calls parachains, or what in the Cosmos ecosystem they are called. I actually forgot what they're called, but they have a name probably there. I don't know, app chain or something like that. Okay, and finally, I would say the last evolution of blockchains is hiding all of this complexity from users. So let's put it this way. We have this like blockchain computers that have like this 4 or 5 properties I talked about, maybe even more properties. But at the moment when you want to sell this to someone, it's like you're giving them the raw thing. Like they have to like understand every single detail of it. Their coding environment is really weird. You cannot have like a long process. Everything has to be divided into blocks. You have to deal with fees. You have to deal with weight. It's just not a user developer friendly environment, frankly. And the idea is that how can we give a platform to developers that allows them to write applications that utilize the same platform without letting them deal with all the underlying stuff? There's not a lot of like players in this realm so far. Polkadot with Jam is moving in this direction. So if you follow like some of the Jam talks from Gavin Wood, you'll see that he has demos where he's running like a game on a blockchain. It's demonstrating that you can have a program that is written like a normal program that runs on a computer, and you can now upload it to a blockchain without needing to deal with fees, block weights, and so on and so forth. There's a few more. I'm not like super familiar with them, so I won't like particularly comment on like whether they're really good or they're really bad. But like two of them are ICP, like the Internet Computer, and there's a new one I found called AR.io. I think at least from the landing page, it seemed like they have similar opinions. All right, so that's like the introduction I have so far. I'll pause briefly if there's any questions so far, and if not, I'll continue for a little bit more, and that would be it. Again, everything I've said so far, so it's like my understanding of like the properties of these systems. I hope it has also added to your vision of like what these systems are, or at least given you some breadcrumbs to like then follow or read upon later. And then I want to look at like these properties and see what we have solved with it. So what have we done with this technology that has been successful so far? So the big success has been commoditizing trade, like creation and trade of digital goods. So in the past, it was kind of hard to sell digital goods, harder to sell digital goods on the internet, because very often you had to like trust one. In the past, you had to like usually trust the platform that sits in the middle. They might have like high fees. They might like screw at some point. Now it's like anyone can create it. You know, if you want to create a meme coin, super easy. If you want to create your own token, super easy. If you want to do like fundraising, do an ICO, super easy. All of these things are now possible thanks to the technology that we have created in the past decade. And they are possible, crucially, without intermediaries, without like extra hoops and steps. And this is why we call it like commoditized. You know, at this point, no one can run a business anymore that, you know, helps you launch a, you know, kind of like fundraising, because why would you go and do it through like an intermediary when you go to, you know, a blockchain and do an ICO for free without any intermediaries? So that's kind of cool. And I'm also phrasing it as a general thing. Like I'm not saying like DeFi specifically or ICO specifically. I'm saying commoditization of creation and trade of digital good. I forgot to put creation and trading in my slide. And this covers many things. So stable coins, DeFi, game assets. It's also interesting. You know, when you think about like what are like valuable digital goods that we have, so we can create them, we can sell them, and we can buy them. The obvious one is internet money, so stable coins. Then it goes further and further. So, you know, I don't know, I'm not really into games, so, but I know there's tons of games who have like, you know, assets in them. That's also kind of like money. And same with NFTs. I used to really not get what the NFT hype is about. Honestly, now I kind of respect it more. I think there is something there. You're creating a digital object that maybe has value depending on what others think of it, and then you're trading it. And this process can definitely benefit from the technologies that we have. And if I take it a step further, one of the ideas that I've kind of come to realize recently is that another sort of like digital good that we have and we trade is computation and storage itself. You know, now there's an arms race for all the big tech companies in the world to gather all the GPUs in the world so they can trade their models and so on. And this is in some sense also a digital good that we can potentially integrate into blockchain systems and, you know, build a better system out of, such that, you know, you can rent, for example, CPU, GPU storage easier, or you can sell it in an easier way because it's still a digital good. So these are overall, I would say, things that we have solved pretty well. The chart is also, as far as I know, or as far as I remember, the TVL of all DeFi based on DeFi Llama. Pretty high numbers, so I would say success. What we haven't solved yet, but it really seems like we're going in that direction, is also like integrating payment and money into the internet. So this doesn't really exist right now. Every sort of merchant, every shop has to bring their own payment providers. Specifically, there are intermediaries who do that, like Stripe. And actually, there happens to be like some sections. I found one of them in the HTTP standard that are related to payments. But when they were writing these documents, supposedly in the year 1999, they didn't have a solution. So they left the segment empty, like, you know, this code is reserved for future use. I think someday the technologies that we're building here could potentially be replacing this. So that's something that I think we are kind of close to. But frankly, when we look at all of this, when I look at all of this, I think still there's a lot of things that we have failed to deliver. There's a lot of like products that were promised and they didn't come into the market. Or put differently, the amount of money that exists in this ecosystem compared to the number of products and use cases that there are still hugely imbalanced. There's way more money than use cases. And question is, why is that? Like, why we haven't found more use cases? I have some ideas or some guesses. Some of them could be due to scalability. So we wanted to build things that particularly suffered from that last property that we were talking about, because the blockchain computers are super, super slow and expensive to use. Anything that needs a lot of computation or storage would become economically unfeasible. So that doesn't work. Sometimes it's because of stickiness. And then, you know, if you want to like compete with a massive platform that already, you know, has all of its users sticking to it. I think the best example is Apple, for example, is an extremely sticky ecosystem. Once you put your toe in, you get sucked in and it's impossible to ever leave. Sometimes it could be due to stickiness. And sometimes I think it's actually because of a lack of like product market fit, as in we have built products that are not sort of that are not what the market wanted and are not what the technology can solve in the best way. And this is actually this, if I'm phrasing it, let's say properly, I would say this last one is what I want to delve into a little bit further. In that I really believe that we haven't like spent the time to fully understand what this technology is, and we have jumped into trying to build products with it. And therefore we have built things that frankly sometimes just don't make any sense at all. So I would phrase it a bit as such that, in order to find the right product market fit, we need to first like really understand what this technology is doing. And then we can find a problem based on those properties that this technology can solve. And then we can see if the market wants this problem to be solved, right? It's like this 2 steps. And yeah, I don't see like a lot of discussions around this, therefore this talk. And to give one example, I really, really think like the success of DeFi is not like a random coincidence. I'm not sure if someone deliberately found it. Maybe it's a coincidence in that someone randomly invented it and then they're like, shit, this is, really good. But if you look at like the things that I talked about earlier today and DeFi, it makes perfect sense. So what are the properties of this computer that we discussed today? And then look at what are the requirements of DeFi. So DeFi is a social interaction where I'm trading valuable things with other people. It then needs a truthful computer to sit in the middle and be the intermediary. It's all on digital data, minus the real world asset stuff. But most of the things traded on DeFi are digital goods. There's no like, Rolexes being traded on DeFi. Extremely simple computation to do DeFi, maybe except for like the order book stuff, which eventually got solved. Very simple computation. There's no like gradient descent in DeFi. It's just subtraction, addition, multiplication, and so on. And finally, I would say thanks to the fact that we didn't have identities by the time that DeFi was picking up, everyone was using accounts that are pseudonyms. So you have some ways to shield your identity. And therefore, the publicity also kind of become tolerable. People happen to be okay with the fact that, if a whale trades on the DeFi platform, everyone sees it. And this kind of became tolerable because everyone was using pseudonym accounts. So really, I mean, again, I don't know if this is a coincidence or not, but I think in retrospect, it's not a coincidence in that this use case happens to check multiple boxes on the properties of this technology. And I think this might yield a good methodology to find something else that could be as successful as DeFi. So something I would actually like take away from this is that while preparing this talk and here, I have found it really, really useful when people question me on these fundamental topics. For example, I'm talking about something that has been built on actually Polkadot for, to not go too far in terms of examples, or any other blockchain. And someone asked me, yeah, but why do we even need to build this thing on blockchain? Like, why does it even need to be like that? And I think this is like a really, really good question to be asked. New joiners, I really encourage you to not think that asking this question means you're missing something. No, I think you're actually you're not missing anything. You're actually getting it because you're kind of like going to the main question that we need to find the right use cases for this technology. And certainly there is some, but finding it wouldn't be a arrow in the dark. It needs to be a deliberate search. And for that, we need to ask these questions. Or another example that I've been playing with sort of friends and family recently is that look into your day-to-day life and the apps and the platforms and the websites that you use and see in which of them you're using an intermediary that is operating on data and computation that meets the criteria that we talked about. So it's all like some digital information. This intermediary is, acting as the middleman. It's a social interaction, so you're dealing with other humans, and the other things that we talked about. Or for example, if we want to go further into the example, it's not a computationally expensive task. And then maybe this is a good use case for blockchains. All right, that was my closing thoughts. Thank you for listening, and now I'm happy to take more questions.